Hey everyone, in this video we are going to cover chapter 8. So I'll go over the most important thing. If you have any questions, please don't hesitate to ask. All right, so as you can see, there are two topics, searching and sorting. And basically, we are going to learn the different approaches, different ways, different algorithm in searching. Because there are many, we're going to choose only two: linear, sometimes called sequential, and binary search. And about sorting, we're going to learn also there are different algorithms, different approaches. So we're going to compare just two examples: bubble sort and selection sort. So the purpose basically is to see which one is more efficient, which one is faster. So let's start with searching. So the searching, the one normally that we normally use, if I ask you, for example, you have an array, a list of values, whatever they are, and I ask you to search for a specific element, you are most likely to use the the linear search. So you're going to start basically, you're going to use the loop, start from either index 0 or from the end, it doesn't really matter, but you are going one at a time, index 0, index 1, 2, 3, 4, until you either find what you are looking for or you are going to get to the end of the list and then conclude it's not there. Okay? So let me show you first the algorithm here. So this is an example of an array, as you can see right here. Now the list does not have to be sorted. Unlike binary search, it has to be sorted. So when you are using linear search, this requirement is not there. All right, so let me show you the binary, how to find an element using linear search. As you can see right here, so you have an array, and this is the searching number, whatever target. So you are going to start from 0, which is the first index. As long as k is less than the size of the array or list, and it's not found is false, you're going to keep looking. When you find it, then you change found to 2. Otherwise, you move on to the next one, k++. So here you have only two possibilities. Either it's found, then return the location k, or negative 1. So it's very straightforward, simple, easy to understand. Now, for the binary search, first of all, remember the requirement is that they have to be the list has to be sorted. So as you can see, like here in the example that I gave you, the assignment. So here, can you see like the list is sorted: -4, -1, 8, 10, 13, 15, 19, 23, 24. So it is in order. And the index, of course, 0, 1, 2, 3, 4, 5. But the way binary search works, you need to have basically three variables that you can keep track of. So the one that is the low level or the low index, and then the high index. So for example, here, let me see if I can get something to write with. Mm. 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 Let me see here. Mm. Hmm. Hi, Lena.
Hi.
Right. Hi, how are you? Thank you for
Good.
joining. Okay, so I just started talking about the searching algorithm. I just explained the linear search. Now I'm explaining the binary search. So as I said in the example right here, you have to use binary search, you need to make sure that the list is sorted. It doesn't really matter, ascending order, it does not really matter, but it has to be sorted. As you can see here, that requirement is met. Okay. Now, the first question, what is the first element of the list? Now, for binary search, we always look for the middle number, the middle index. So, for example, here, what is the lowest index here? Is 0, right? This is 0, what a -4 is. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So here, the lowest index is 0, and then the highest is 11. So how can I find the middle index? Because sometimes you may have like an even number, sometimes you may have an odd number. Regardless, you add them up. 0 plus 11, that's 11 divided by 2 is 5, right? Because integer over integer is an integer. So what is 5? Which one is 5? 0, 1, 2, 3, 4, 5. So that's 15. So this is 15. So 15 is the first number to be compared, whatever I'm looking for. So here, it doesn't matter what you are looking for. In the other examples, it will tell you like which number to look for. But here it says, regardless what you are looking for, what is the first number you're going to compare? You're going to compare it to, and that's 15. So here, the first element is 15. For number 2, what is the second element that you're going to be examined? We already said that 15 is the first one, right? So if I'm looking for 28, now since the list is sorted, I'm going to compare first 15 to 28, right? So 28 definitely is bigger than 15. It's like we are splitting the array into half. So we have the right side, the right array, which is from 19, because we already know 15 is not there. So from 19 to 31, that's the right side. And then we have from -4 to 13, that's the left side. Now, since 28 is higher than 15, then definitely 28 has to be on the right side. So I can just ignore all the numbers from 15 to -4. I'm not going to even look at them. So now the lowest index will not be 0, will be where 19 is. It's like I'm focusing only on that half. So I'm going to start from, we already know that 15 has index 5. So from 6 to 31. Now 6 is the index of 19. That's going to be my lowest index. And then 11 is still the highest index. So 6, I'm going to show you this, and I'm going to give you another example in case
Okay.
it's not clear to you. So here from 6 to 11, so 6 plus 11 is what? 17, right? Divided by 2 is 8. So 5, 6, 7, 8, that's 24. So the second number that I need to compare 28 to is 24. So let me see, I'm trying to see if I can find like anything to write with. So let me see here. Usually you have, well, they have it in the whiteboard, I think. Well, I'm going to do a whiteboard in a minute. Let me just finish this one.
Okay.
So we said 24 is the second number. Now 28 is still higher than 24. Now what do I have left? I'm going to again divide it into half. So now I have only 3 numbers left because I know 28 higher. So I have only 3 numbers left. Always looking at the middle. So 30 is the next number. So 28 is less than 30, so you're going to look left. And the only number left is 28. So how many numbers did I compare to 28 to find 28? It was 15, 24, 30, then 28. All right? So number 3, again, when searching for 25, now 25 is not there, okay? But still you're going to follow the same thing. You're going to keep basically shrinking that array until there is no more numbers. until basically the lowest index to highest index will overlap. So when the lowest index becomes bigger, that's how the computer finds out that there are no more numbers and it's time to stop. The number is not found. And I'll give you a minute. I'll give you an example in a minute. So for 25, again, we're going to start with 15, right? 25 is higher than 15. Now it has to be on the right side. So here we have from 19 to 31. Again, 24, right? 24, 25 is still higher. So we have only 3 numbers left. So I'm going to compare it to 30. Now 25 is on the left side. So we're going to compare it to 28. Now there are no more numbers left to the left. So that's how the program finds out that there are no more numbers left. It's time to stop. The number is not found. But you compare 25 to 15 to 24 to 30, always the number in the middle. Okay? So let me give you an example here so it becomes clear to you. I'm going to use the whiteboard. Okay? So this is the whiteboard. I'm going to get a new one. Can you see the whiteboard?
No.
Okay. I'll probably have to. Let me click on it. Can you see it now?
Yes. Now it's loading. It's loading.
Okay. That's coming. All right. So now I'm going to use this. Okay. So let me give you a number, a bunch of numbers. Remember, they have to be sorted. Okay. But let's say here we have 2, we have 4, and then I have 7. Remember, as long as they are sorted. And then I have 9, for example. Okay. 9. And then I have, let's say, 13. And then I have, let's say, 17. And then I have 20. And then I have 24. Remember, you cannot use binary search if it's not sorted. So 1, 2, 3, 4, 5, 6, 7, 8. Let me add 2 more. And then we have, let's say, 30. And then 34. Okay? It's very important that I use the index so I can know the location. So we have 0, we have 1, we have 2, we have 3, index 3. We have 4, and then we have 5, and then I have 6, and then I have 7, and I have 8, and finally I have 9. Okay. So I need to have 3 variables. I need the first one, this is the lowest index. Let's keep track of the lowest index. And then, because remember the array keeps shrinking. So either the lowest will change or the highest will change. So by default, the first one is 0, right? But that's the lowest index. The highest index is right here, 9. So we have the highest index. So I'm going to put here 8. It's going to be 9. And then always the middle one, the middle index. You add them up and then you divide them by 2. So here basically I'm going to put 0 plus, because when you divide by 2, you're definitely going to get one number. There's no 0.5. So you're going to divide by 2 after you add them up. So that's going to give me what? 9 divided by 2 is 4. And it says 4.5, but remember, we just ignore 0.5 because we divide integer by integer. So now the number I'm going to compare, I'm not going to compare it to 2 or 4. This is linear. Linear starts from the front, right? And then I'm going to put, okay, let's say I'm looking for, I'm going to give you 2 examples. One example if the number is there, and then the other, what about if it's not there? So let's say, for example, I'm looking for number 24. So 24 is the number to search for. That's the target. Okay? This is my target. So I'm going to compare 24 to whatever the whatever the middle number is. So the middle number we said is 13. Why? That's the one has index 4. Remember? Index. So now I'm going to say, okay, 24, is it higher? Well, is it equal? No. Because if it's equal, that's the end of the story. That's it. I'm just going to return number 4. And then that's the best scenario. The best scenario is the middle number. I'm talking about binary search. The best scenario if the number is exactly in the middle. So imagine I was looking for number 13. If I use binary search, it will take one single pass, one single comparison. Now 24 is higher. If it's higher than 13 and the numbers, I know they are sorted in ascending order, then it has to be on the right side. There's no way for 24 to be on the left side. That's why binary search saves us a lot of time, because always half of the list will be ignored, will be basically just, crossed out or something. So now I'm going to focus on this. Now, am I going to search right or left? Now 24 is on the right side, so I'm going to search right. If I'm searching right, that means I'm going to start from 5 now, which is the middle 4 plus 1. So this lowest will be whatever the middle index is 4, and then you add 1 to it. So now I'm focusing on half of the array. That means basically this part right here, all the way to here. See? You keep always, every time you split it into half, just by focusing on the middle number. Now 5, no, the highest 9 will not change. You cannot change both of them either. So you are searching left. If you are searching left, you are changing the highest by subtracting 1 from it. If you are searching right, then you are changing the lowest index by adding 1 to the middle one. So now I'm going to go 5 plus 9, that's 14, divided by 2 is 7. So what is 7 now? 24. Oh, so it took me 2 passes to find 24. Why? Because here 24 is equal to 24. You always look at the middle number. So it took me how many? 2 passes to find 24. So here found after. So this is the binary search. But if I use the linear or sequential, how long is it going to take me? How many passes? Remember, this is just like a simple example. But in real life, we're talking about millions or even billions of numbers that you have. Imagine like big companies or maybe like a government agencies like IRS or, FBI, CIA, big, huge companies. So it makes a huge difference. So for us, because somebody may say, well, what's the point? I mean, the computer is so fast. So it doesn't matter which one. Yes, I agree. If the number is limited, like you have like talking 100 or something, you may not even see the difference. But if you are dealing with huge numbers, definitely there is a difference. So here it took me 2 passes to find. If I use linear, I have to compare 24 to 2, to 4, to 7, to 9, 13, 17, 20 to 24. So it means 1, 2, 3, 4, 5, 6, 7, 8 passes, 8 comparisons. Okay? So now let's give an example of how does the program or the code know that the number is not there. So let me, let me come up with another example and then, okay. So let's say we have different numbers. Let's say 3, we have 5, we have 6, and we have 8, we have 12, and then we have 2, and 16. So let's say here 19, and then we have 21, 29, and then let's say 40. So the first question is the list sorted? Yes. Okay, now I can use binary search. Now what about if the list is not sorted? Then the only choice you have is linear. All right, now let's look for something that is not there. So let's say I'm looking for number 7. Okay, 7 is not there, right? So how does the program know that the number 7 is not there? We always start from lowest index, highest index, and then the middle index. Okay, so we always do start with lowest is always 0, and then the highest is the highest index, which is in this case 9. So again, you add them up, you divide them by 2. You will have only one number, there is no 0.5. 9 divided by 2 is 4. So now I'm going to compare. So we have 0, 1, 2, 3, 4. So here I'm going to compare it to 12. So 7, is it less or higher? So of course less than 12. Which means which side I'm going to search right or search left?
To the left.
Left, right? Left. So when you are searching left, which one will change? The highest index or the lowest index? Because now the list is shrinking, the array is shrinking.
For the
you said the
middle.
left side, right? So the left side, that means this side, to the left of 12.
So
that means the
zero.
lowest will never change, it's still 0. But the highest index now is what?
Is 3.
3, which means whatever the middle index, which is 4 minus 1. So this is 0, and this is 3, which is this guy right here, 4 minus 1. If I'm searching right, I will add 1 to it. But this is for the lowest index. Now I'm going to add them up. Continue the process again. 0 plus 3 divided by 2 is 1. I know it's 1.5. It doesn't matter. You just get the integer part of it. So you have 1. So what number is 1? It's 5. So now 7 is higher than 5, right? Pay attention here. Remember that now we cross all of these numbers that they're out of the picture now. We have only those, right? 4. And then we said 0 plus 3 divided by 2 is 5. So 5, when you have two numbers in the middle, we usually get the one on the left side. So 7 is on the right side. That means basically I have only two numbers left, right? So if 7 is higher than 5, I'm going to search right. Because 7 is on the right side of 5. Okay? Now, what did they say? If I'm searching right, the lowest will change. It will become 2. How did they get 2? The middle one, the 1 plus 1. And then the highest will not change at this point because I'm searching right. And then you continue. 3 plus 2, 5 divided by 2 is 2. Okay? Which means which number is 2? 6. So 7 is still higher than 6. So I'm going to search right again. Look, either search right or search left. If you are searching right, you add 1 to the middle. Okay?
Okay.
And then if you are searching left, you subtract 1. So here I'm searching right. So what's going to happen? I'm going to add 1 to 2. So I have here 3, 3. So 3, add them up. 6 divided by 2 is 3. So that's the last number I have. So 3 is 8, right? So 7 is what? Is less than 8. Here, pay attention because that's how the program will find out that it's not found. So I'm going to search left. If I'm searching left, I'm going to subtract 1 from the middle. So it becomes 2 here, and the lowest will be here. Look what happened. The lowest becomes bigger. That's how the program stops and say it's not found, not found. Because look at 0 is less or equal than 9. 0 is less or equal. So the lowest is always less or equal. Once it becomes, that means basically they overlap, 3 becomes bigger than 2. That's how the program finds out it's time to stop. The number is not found. That's why when you look, the code. Let me show you the code here. Let me share the code so it will make more sense to you now. Okay, so let me see the code. What is the code for? The code for, there we go. Can you see now how many variables? It should make sense to you now. Okay, we have a variable called found. By default, we're going to say it's not found. And then once we find it, then you're going to change it to true. Look how many variables I have. The lowest by default is 0. The highest, whatever the length is, -1. That's the last index. And the middle, you don't have to put 0. Don't put any number. So look at the code. While, the best translation for while is as long as. As long as the lowest is less or equal, that means there are numbers left to be processed, and the found is false, that means as long as there are numbers and you did not find what you are looking for, keep doing the same thing. Add them up, divide them by 2. That's exactly what we've been doing. You add them up, you divide them by 2. That's going to give you the middle index. And then you compare. If it's equal, that's the end of the story. You return the location. Okay? But if it's not, then you have two situations. Either you're going to search right or left, depending if, okay, like here, for example, what I'm searching for, so searching number, that's what SN is. If it's higher than the middle number, then I'm going to search right. And in this case, the lowest index will change by adding 1 to the middle. That's exactly what we've been doing. Else, we're going to search left. And if I'm searching left, then the highest index will change by subtracting 1 from the middle. So you're going to keep doing this over and over. That's how you have the loop. Either you're going to find what you are looking for by focusing only on the middle, or you're going to keep shrinking that array, that list, until either you'll find what you are looking for, or you're going to get to the end when there are no more numbers to the point that lowest and the highest index, they overlap. That's why you have the lowest becomes bigger. If it becomes bigger, that means that's it. There are no more numbers left. And then at the end, you put if found is true, you return the location. That means the index. Otherwise, return negative. All right. So this is by a binary search. So if I go back to the assignment, then it should make sense to you, because here it's asking you when searching for 25, so you're going to follow the same process I was. And then if you just watch the video, because I did something similar in the video, so you should have no problem find it. Just make sure you watch the video and go step by step. Okay. So when searching for 20, when searching for -1, let's go for -1 as an example. So -1 is right here, but the program is not going to start from here. It's going to start from the middle, which is 15. So you're going to compare -1 to 15. The first number to be examined is 15. Now 15, -1 is less than 15, so it has to be on the left side. So now I have only the numbers from -4 to 13. So the middle number is 0. That's the index of -4. What is the index of 13? 1, 2, 3, 4. So 4 plus 0, 4 divided by 2 is 2. That's where 8 is. So the second number will be 8, because it's in the middle. Now -1 is less than 8. That means I have only two numbers left, 0 and 1. So if I add them up, 0 plus 1 divided by 2, that's going to give me 0, which means I'm going to search -4 first. Then I have only one number left on the right side. That's going to be the last one. So how many numbers I examined or compared? It's 15, 8, -4, and -1, because I'm looking for -1. So it depends like what number are you looking for. All right. Now, how about 31? Let's say I'm looking for 31. You always start from 15, right? So 15, 31 is higher than 15. Now I'm going to go from 19 to 31. So 0, 1, 2, 3, 4, 5. So we have 6. 6 is the index of 19. 6, 7, 8, 9, 10, 11. So 6 plus 11, that's 17, divided by 2 is 8. So that's 24. Now 31 is to the right. So I have only 3 numbers left. And always I look in the middle, 30. 31 is on the right. So I'm not going to search 28. Why? Because 31 is on the right. And that's the only one number left, which is 31. So I will examine 15, 24, 30, and 31. I hope this is clear. Okay? So all of this question is about the same thing. Just what elements, what numbers are you going to compare with your target? All of this is the same thing.
So we give you the middle each time.
Yeah,
And
always
okay.
the middle. If you have two numbers in the middle, it's the one on the left side. But if you follow the process that I showed you, you put lowest, highest, search right, search left. Either you're going to add 1 to the lowest, or you're going to subtract 1 from the highest. I'm sorry. So if we're searching right, you're going to change the lowest index by adding 1 to the middle index. If you are searching left, you are going to change the highest index by subtracting 1 from the middle. Just look the example again. It would. Let me add one example before I move forward. So let's say I'm looking for, let me answer that one question. Let's say 13, okay? Number 5. But again, the middle number is always the first one. So is 13 higher or less than 15? It's less. So now I'm going to search the number, the left side from -4 to 13. I don't want to, don't include 15 in your next search because we already know 15 is not what we are looking for. Why should I include it in my second next search? I have only the numbers -4, -1, 8, 10, and 13, right? So if you have only one number in the middle, which is this case, 8, then that's the one you're going to look for. If you have 2, that's the one on the left side. So now the next one is 8. Now I know 13 is on the right side. How many numbers I have left now?
2.
2, 10, and 13. So when you have 2, always the one on the left side. So you're going to compare it to 10, then 13 on the right side. So what numbers did you examine? 15, 8. This is what I was looking for, 13, right? So I examined 15, 8, 10, and 13. Because when you have 2 in the middle, you always search the one on the left side. One more example. Let's say I was looking for number, okay, we already did 28. Let's say if I was looking for number 10, I probably would just did it. So it's going to be 15, 8, and 10. What about if I'm looking for number 19? The first one is always 15. And then the right side, you have 24. And I have only 2 numbers left on the right side. So it's going to be 19, the one on the left side. If I was looking for 23, then I have to search 19 first, then 23. Every time you have to choose the middle, always the one on the left side. All right, so this question should be easy. So number 6. What about if I was looking for number -12? So we always start with 15, right? So 15. And then where is -12? Is on the left side. So number 8 is the middle. So now I have only 2 numbers left, right? Negative. So I have only 2 numbers left. So the one on the left side, I'm going to compare -4. Am I going to compare -1? No. Why? Because -12 is on the left side. Why should I look on the right side? Yeah, did you see the difference? So 15 is the first one, 8, then I have -4, then there is no more numbers. Why? Because -12 is on the left side of -4 and I have no more numbers left. So to search for number -12, you examine 15, 8, and -4. That's it. And then find out that it's not there. All right. So that's it. This is the questions. When searching for 11, what number will be returned? Now, according to the code, it's going to return the location of number 11 if we have one, if it's there. Now it looks like there is no 11 here, so it's going to return -1 because -1 means it's not found. Now number 9, there is a short video I did. I think the second one. It says more about search. It tells you like if we have a big number, we can predict, because remember we keep splitting the array by half every time, so we can predict pretty much what's the maximum number of comparison we can make. Even if we don't know exactly what we are looking for, you can predict the worst case. That means how many what's the maximum number. So how do you do it? It's very simple. You put 2 to the power of n, and then you see what is the value of n that's going to get closer to 500. So 2 to the power of 10, I think that's 1024. That's more. Now I'm going to go down. 2 to the power of 9, that's 512. That's the one. So 9 means that 9 is the maximum number of comparison that it take, regardless. Either I find what I'm looking for or it's not there, but I'm not going to go beyond 9 comparison, 9 examination. Okay? So you always use the power, 2 to the power of n, and you try to find the value of n that gets you closer to the number. But it has to be higher, but the closest one. Now for sequential, you have to look at all of them. The worst case is use visit every single, so 500. That's it. Now let's move on to sorting. Okay, how do we do? We have there are actually many types of sorting algorithm. There is quick sort, there is a merge sort, there is insertion sort, there is selection and bubble, and even more than that. So we just picked 2 of them, just so you can see and compare them in terms of efficiency. All right, now let's start with the bubble sorts. So if we have this list, of course, you're going to have unsorted. That's why you want to sort them out. So the bubble sort states that you're going to keep comparing the 2 consecutive elements. That means the first and the second and the third and the fourth and and so on. If they are in order, you don't touch them. If they are not in order, you swap them. So now 4 and 6, right? So 4 and 6, they are in order, so nothing will happen. Now 6 and 1. Huh?
It's not the whole list that needs to be in order, like for the binary search.
Yeah, for binary search, it has to be sorted. But for the sorting, of course, we don't have it sorted because that's what the purpose is to put them in order. Yeah. So as you can see, 4 and 6, we put them in order, right? But they are in order, so we're not going to touch them. Now 6 and 1, are they in order? Of course, assumption is we are doing it in ascending order from the lowest to the highest. So 6 and 1, are they in order?
No. No.
They are not. So if I swap them, then 1 is going to be to the left and 6 will be on the right side. Okay, can you write down this? So I'm going to do it in the whiteboard, okay? So
okay,
let me stop, but I need to remember this number. Can you remember? Can you write them down for me? Because I'm going to switch to the whiteboard so I can show it to you in there. So let me stop. So just write down these numbers because I'm going to ask you to give them to me.
Okay, it's done. I wrote them.
Yeah, let me open the whiteboard because it's for this kind of you need to show it. You know, I mean, just talking about it's not going to help. Okay, what's the numbers, please?
4.
So we have 4.
6.
Second one, 6. Okay.
1.
Then we have 1.
9.
9.
3.
3.
And 8.
3. 8.
Yes, and 7.
And last one?
Yes, last one is 7.
7. Okay. How many numbers we have? 2, 4, 6, 7, right?
Yes.
So I'm going to compare. This number 1 is the one I'm about to do. So 4 and 6 are in order, right? So I'm going to put here 4 and then 6 here, right?
Yes.
Okay, I'm going to put 6 here, but it's not going to stay. Now 6 and 1, they are not in order. So what do I have to do? I have to delete this and then put 1 here. 1. See here I have 1 and then 6 here, right?
Yes.
Then 6 and 9 is in order, so nothing will happen. Now I have 9 and 3. I'm going to swap them. So I'm going to put 3 here and then 9 here. But look at 9 and 8. They are not in order. So I'm going to swap them. I'm going to put the 9. 8 will be here. 8 will be here. And then 9 will be next.
Okay.
I have 9 here. But look at 9 and 7. They are not in order. So again, I'm going to swap them. So I'm going to have 7 and 9. See, this is the first pass. This is what happened to the array after the first pass. Now, you may notice that the biggest number will make its way to the end. Look, 9 was in the middle, and then it became the last one. That's why they call it bubble, because the biggest number will bubble up to make its way to the end. That's the reason they call it bubble. So now it's not going to change, 9. All the other numbers may change position, but 9, it will stay here permanently.
Okay.
So that's the first pass. And then I'm going to continue. So number 2, again, 4 and 1. So I'm going to put 1, swap them, and 4 here. 4 and 6, they're in order. 3 and 6, I'm going to put 3. And then 6 right here, right?
Mm-hmm.
And 6 and 8 is fine, but 7 and 8 is not. So I'm going to put 7, 8, and 9. This is the second pass. Can you see that again? The next biggest number will make its way to the end. So these two numbers will be permanently in their position. And then you continue all the way. Sometimes you may get them sorted before the end because it takes, how many numbers do we have? 1, 2, 3, 4, 5, 6, 7. It will take n minus 1. Basically, it will take 6 passes to finish the process, to finish the sorting. Okay, but sometimes you may end up sorting maybe like halfway. Sometimes the numbers, somehow get sorted before, but you still have to continue. Even if it gets sorted, let's say halfway, you have to finish n minus 1 passes. Now let's continue with this.
Write the same number.
Yeah, exactly. You repeat the same numbers because the program does not know that you have them sorted. And it's like you have a helper function or method that will check every time if it's in order or not, which we don't have here. So I'm going to continue here. We have 1, 3, and 4. Like in this case, look what happened. 3, 4. Can you see like the numbers now? They are in order, even though we did not finish the entire process. But for this pass, only the last 3 numbers were permanently. Because in every pass, you just secure 1. So now we have this, and this. Now you can tell, okay, now, but the numbers are sorted, but the program does not know. We still have to continue. Number 4, you repeat the same numbers for pass number 4, number 5, and 6. So you're going to add 3 more passes with the same numbers, even though they are the same, no change was made, but you still have to go through the process. Does it make sense?
Yes.
So this is what the bubble sorts work. You keep comparing the first and second. If they are in order, you keep them that way. If they are not in order, you swap them. And then you go the second, third and the fourth, and then you keep doing this. Now for the selection, and I don't want you to get confused here, I'm going to use a different algorithm here. Okay, so what about selection? Selection, as the name implies, so basically you pick the smallest number in the list. Now, what is the smallest number in the list here?
1.
1. Where is it supposed to be? What's the right location for 1 if you are sorting the numbers in ascending order?
0.
Supposed to be here, which means I need to swap 1 and 4. Why? Because 1 is supposed to be here. This is the right location. I'm going to swap 1 and 4. Everything will stay the same, will stay intact. So now and 4, I swap them, but 6 will stay where it is. 9 stay where it is, 3 stay where it is, 8 will stay same place. So the only number that's going to be permanent is this, because we know that this is the right location for 1. Everything else may move, may change position.
Okay.
Now you're going to repeat the same thing for number 2 or past number 2. What is the next smallest number after 1?
3.
It's 3. So what is it supposed to be? Here, right? So we're going to swap 3 and 6. Everything else will stay the same. 4, 9, 8, 7, and then 1. So now 1 and 3 are in the final location. Everything else may change. Now, can you see like number 4 is in the right location? So
Yeah.
that's past number 3. Even though I did not make any change, it still counts as a pass. Why? Because it just happened that it is in the right location, but I still have to count it as 1 pass. So here we have 4, 9, 6, 8, and 7. So now after 3 passes, the first 3 numbers will be in their final location, permanent location, which means if the first 3 numbers are the smallest number, that means I'm more likely using selection. If the biggest number are at the end, then you are most likely using a double sort. This is just, sometimes like you may be asked what algorithm are you using. So you may use this remarks, to help you with you don't have to do it like from scratch. Now, number 4, let's continue here. Remember, number 3, we didn't make any change. Why? Because 4 was in the right location, but we still have to repeat that. Now, number 4, 6 and 9 would be swapped. So 6 and 9, because 6 is supposed to be after 3. So that's 1, 3, 4, 8, and 7. So now, after 4 passes, this is the first 4 numbers will be the smallest numbers in their final location. Now, pass number 5, what you're going to do for pass number 5? What kind of change or swapping you will make?
Swap 7 and 9.
7
and 9.
And 9. Really good. I'm sorry, I have cat next to me. It's making that noise. Okay, so 5. Number 5, so I'm going to swap 7 and 9. So I'm going to put 7 here, 9 here, and then 8. So now it looks like the numbers are in order, but still, how many passes you have to make? You have to have, if you have 2, 4, 6, 7, you have supposed to have 6 passes. So now 4, starting from 5, sorry, here we have 1, and then 3. So from 5 all the way to, so and you have only 2, 4, 6, 7. Yeah. So you have, what is it? Yeah. So 5 and 6 will be exactly the same. 5 and 6 passes, pass number 5, number 6 will be identical. So that's basically how the selection works. So you look for the smallest number, and then you swap it with the number at index 0. In pass number 2, you get the next smallest number, and then you swap it with the number with index 1. And then you continue all the way to the end. That makes sense?
Yes.
So let me just stop this, and then see here if you have any questions about this. So we went over this. So I'm gonna go to the bubble. We talked about selection. Remember, the smallest number, which is 2, you swap it with 20. Everything else will stay the same. And then, now 20 is in the second place. You're going to swap it with 10, because 10 is supposed to be in the second position. So it shouldn't be a problem. Any questions about
No, it was clear.
All right, so now I'm going to explain program number 1. This is basically just you're going to copy the code for binary search. Because here, look, write to program, and I put a run sample. So you're gonna ask the user to give you like what numbers, how many numbers to sort. Like as you can see in the example, how many random integers? Let's say it's gonna say 200. Or give me the lowest value. Okay, number 10. Give me the highest value, let's say 10,000. Now you are going to generate, you know how to generate a random number, right?
Yes.
Yeah, if it's not, I think probably I have a video in there or a link. So, so what you need to do, you are going to create an array and then assign a random value 200 times. Because remember, the first question was how many numbers to be processed. So you're going to use that as the length of the array. And then you know the lowest to highest. So you're going to generate 200 random numbers between 10 and 10,000 because we need to have numbers, right? So we're going to use just random to assign the array these random numbers. And then you're going to just guess, like any number, enter a number to search for. Now, that number may be there, may not be there, right? Because they are not random. We don't know. So let's say, for example, it's going to say 41. So 41 may be there, may not be there. So if it's there, so we're gonna copy. You just have to copy. You already have the code, right? So you're going to have a function called binary search. You already have it in the PowerPoint. You copy it, you put it in your code, and then you call that function because that's going to sort it out. And then you're going to return the location. You're going to call the function so we know what is the location of the number if it's there. If it's not there, then it's going to be. So basically, that's what the program is asking. You don't have to come up with anything. The code, you already have it, binary search. Just copy and then paste it. And then you call the function, and it will either return -1, which is probably most likely the case because it's very hard to, But it's possible maybe the number is there, and in this case, like in this case, 41, let's say it was at index 13.
Okay.
So that's basically what the question is asking. I hope it is clear. If you still have questions, please do not hesitate to ask.
Yes, okay.
Lina, everything is clear? Do you have any questions, any concerns?
Yes, no, it's clear. I think I'm going to start like the assignment on bubble and selection sort.
No problem. Well, thank you for joining us. Thank you.
Thank you. It was helpful.
No problem. Anytime. So we're gonna have like a weekly because now the first 2 weeks because it was only review. I thought like maybe there's no point in meeting. But from now on, so we're gonna meet at the same time, 5 o'clock. If you have questions or if you have concerns or you just wanna, attend to enhance your understanding. So please don't hesitate to join us. We're gonna meet at the same time Wednesday at 5 o'clock. Okay. Thank you so much for attending. Thank you.